Okay, so this is the outline for chapter 23. So first we will introduce a variable called the electric flux. Electric flux，中文叫做电通量。电通量 ，okay. Okay, so it will relate to the surface integral, and that is what we need for the Gauss law. And then for the second part is the main topic of this chapter is the Gauss law, which is one of the 4 laws in the Maxwell equations. So it is really important, and we will make use of it later on. And then we will try to use the Gauss law to do some calculation. Okay, actually it will simplify your calculation, but actually the mathematics for the Gauss law is quite complicated. We need the knowledge of the surface integral, but I suppose you have learned it in your mathematical class yet. So yeah, so this is the difficult part here. So, but I try to let you know the physical meaning of the surface integral and then try to use it for some simple case so that this surface integral will simplify to a multiplication only for most of the case, or sum of several products. Okay, so in such a way we will try to use it to calculate some cases like cylindrical symmetry, planar symmetry, and spherical symmetry. Yeah, for some E-field calculation. Okay, in the previous chapter we need to use the calculus. We need to separate the continuous charge distribution into a small part, and then we try to calculate the dE of each part, and then try to sum it together, and then do some cancellation for some of the components. So, and then finally you need to use the integration to sum all the dE together. But here we make use of some complicated math called the surface integral. So we can make use of this Gauss law to simplify the calculation, but the mathematics is more complicated. Okay, so here is the overview of the electromagnetism. So in chapter 32, we will mention the Maxwell equation, but actually, Gauss law is one law in the Maxwell equation, and actually in these textbooks the notation is not the same as this. It's not the same as this. This figure is just to let you know for the Maxwell equation we have a integral form and also the point form. Okay, so you can also consider the integration form, and this one is the derivative form. 就是一个是微分形式，一个是积分形式 derivative. So it will have something like, oh, this is the gradient, and then the cross product, and then this is the dot product. Okay, but actually in this textbook it only mentioned the integration form. It only mentioned the integration form. But yeah, later on I will try to talk a bit about the point form, because we need to use this point form to really derive the wave equation, and then the solution of it will be the electromagnetism, which we will cover in chapter 33. Okay, so actually in this textbook it does not has introduced about this D vector, and actually this D vector is proportional to the E field. Okay, so in this textbook it only mentioned the E field, and then the expression of the Maxwell of the Gauss law will be a little bit different. So here is just to let you know, in the Maxwell equation we have 4 laws. This one we will learn in chapter 23. Okay, in chapter 23, this chapter we will learn this Gauss law, and then this one is another Gauss law for the magnetism. Okay, so the expression on the left side is similar, but the right side is 0 because there is no magnetic monopole, 没有磁单极. Okay, and actually we will cover it in chapter 32. Okay, and Ampere's law is about the B field. Is about the B field, which we will cover in chapter 29, and for the Faraday's law we will cover it in chapter 30. So So we are actually learning this Maxwell equation throughout different chapters, and then finally chapter 32 it tells you that all these four laws are summarized, and then we'll call it the Maxwell equations. Okay, so here is the first variable we would like to introduce in this chapter is called the electric flux. Electric flux, as I mentioned, is the 电通量. And then here is the highlight. It says the Gauss law relates the electric field at point on a closed Gaussian surface to the net charge enclosed by that surface. OK， 中文的意思是说，高斯定律是把那个电场 on a point at point on a closed surface integral， 在一个叫做高斯面或者是一个封闭的曲面的这对于一个封闭曲面，然后有个长的话，我们就可以算那个通量，就是不同的长都可以算。电长的话，它就是电通量；磁长的话就是磁通量，也可以有其他的通量啊。那然后高斯定律的话，就是把这个电的通量通过一个封闭曲面或者是高斯曲面，然后跟这个它所包围的电荷量静电荷 ，enclose 的话就是这个封闭的曲面包围的那个电荷的这个静电荷量。因为这个包含呢，可能是有一些正的，有一些负的，可能在不同的位置，但是它就只跟那个总的电荷量有关，它跟那个位置完全没有关系。OK，by that surface。OK， 所以听起来很抽象，事实上也很抽象。Okay, so let's take a look at this example. Okay, so here， 因为其实我讲有时候重复很多次，有时候同学还是不理解那个东西的，就是有时候你重要的事情讲3遍，但是讲完3遍他还是不懂嘛，可能要讲个10遍但是讲10遍的话我又嫌有点多。Okay, so here on the left figure we have an orange triangle called the Gaussian surface. I don't try to highlight it again. So this one we assume it to be a Gaussian surface or a closed surface. Actually, in this textbook, Gaussian surface and closed surface mean the same thing. Chinese 的话就是高斯曲面或者是封闭曲面。封闭的话就是说，比如说像这个水瓶，盖子盖起来的就是封闭嘛。那如果我把盖子拧开，它就不封闭嘛，就是它有一个缺口嘛。所以就是比如说一个球面，它是一个封闭曲面。通常我们用到的都一般都是就是比如球体或者是圆柱体这种对称的。当然，如果真的要说它就是要满足这个高斯定律，封闭任意形状都可以只是说你要真的用手算得出来的话，它通常都是对称的，要不然是球的，要不然圆柱体。Okay, so here this is the Gaussian surface. Although it draw it like a circle, it's 2D, but actually you assume it to be a spherical. It's to be a sphere， 就是它是一个球体，它是立体的它只是画在一个纸上面，它就画一个圆形而已。但是你假设它是一个球体。Okay, so actually, here we have a Gaussian surface. We assume to be closed, and then inside this Gaussian surface, we have a charge. Okay, assume this is a positive Q. Okay, so it will generate E field pointing outside. Okay, so pointing outside 1, 2, 3, 4, 5, 6, 7, 8. Okay, so one point very important is that the Gaussian surface is not a practical surface. 它是现实上不存在的，它只是一个幻想的东西。高斯曲面、封闭曲面，它不一定要有一个实体，我可以任意假定某一个面是一个高斯曲面，然后我就去算它的通量。 它也许有些情况是有一个求可在那边去算的，但是它不一定要有，它不一定，它高斯曲面的话就是一个 imaginary 的一个面 ，imaginary 的啊，它可以有实体，但是它可以没有实体的。OK， 所以在这个情况的话，它是没有的，它是一个虚线，它就告诉你说，哦，这个是一个高斯曲面，它并没有任何东西存在，但是我可以再算这个曲面的这个点统面。那但是现在的话，就是后面会有一个积分，但是现在的话，我们就数个数字啊，我们这有数1、2、3、4、5、6、7、8，有8个箭头通过它啊，这是。现在我假设它就是 Q 的话有8个箭头通过它 ，OK，and then here if we assume the charge is increased to 2Q, okay, we have 16 arrow going through this Gaussian surface, this same Gaussian surface. Although it looked like a little bit smaller, but actually, yeah, you assume they are the same. But we have 16 arrows going through that because the charge is larger. And then another important thing is that if the charge are positive, okay, the charge are positive, the E field will be going outside. Okay, so for the third case, if we have a negative 0.5 Q, okay, we only have 4 arrows pointing inside. Okay, we only have 4 arrows, and pointing inside. Okay, so inside, outside are important, and then the number are also important. Okay, so here we have 8 arrows, and then 16 arrows for this case, 4 arrows for this case. Okay, so the number of arrows going through the Gaussian surface are proportional to the absolute value of the amount of charge. Okay, something like this. And then the positive side, okay, it means the E field will be going outside, and then if it is a negative charge, the E field will be going inside. Okay, so this is the electric flux conceptually. Okay, let me stop here today.